Okay, so for 7D, we are talking about polynomial inequalities. So I wanted to just remind you of some reminders here, that your answers should always be x values in interval notation. And you are going to have either solid dots or open dots, and that tells you what kind of bracket you will have. If it is less than 0, it will be below the x-axis, and more than 0, it will be above the x-axis. So we're going to bring this with us to the next page here. And we're going to try two problems that are very similar. You will have seen one of these on the notes. So we'll just talk about how are these different from each other. So this first one, I can use Desmos to help me graph it. And when I do, I will see that my graph has goes through -3, it comes back to 1, and it bounces. So it has this shape where we're going through -3 and +1 with a bounce at +1. Now the one on the right has the same graph. So I'm just going to put it there again. Okay, the only difference here is the inequality symbol. So here I have a greater than symbol, and here I have a greater than or equal to. Now on the page before this, the first page of the notes, we also talked about what less than looks like, but I wanted to specifically talk to you about this. Okay, so when you have a greater than 0, that means that we're going to have open dots, and we are going to be above the x-axis. So I'm going to do an open dot at every x-intercept because that's where the function is equal to 0, but I don't want where it's equal to 0. I want everywhere above 0. So I want all of this. You can kind of think of this all as being y. So where it's y greater than 0, that's above the x-axis. But I don't really have y's in here. I put that y in myself. So I'm looking for x values. So my answer is going to use x values. This is what we said, interval notation, low to high of x values. So I'm just going to take this graph and I'm going to squish it down to just the x and y direction, or just the x direction, left and right. And so since it goes forever to the right, that is infinity. And so then I can write this as an interval going from -3. And since it's an open dot, I want to use a round bracket. So from -3 to 1, and then also from 1 to infinity. And infinities always have that round bracket. And the reason that it's two pieces is that I have a break in my solutions, because 1 does not work as an x value. If I were to take this x plus 3 and x minus 1 squared greater than 0, if I were to put a 1 in for x, because by the way, this is my final answer. If I were to put a 1 in for x, what would happen is that I would get 1 plus 3 and 1 minus 1 squared. 1 plus 3 is 4. 1 minus 1 is 0. So this side becomes 0, and 0 greater than 0 is not a true statement. That is false. So I cannot include x equals 1 as a solution. So I have to have a break. So I do have the two pieces to my solution. Okay, so how is the second graph different? The graph looks the same, but the inequality here is telling me that I'm going to have solid dots And greater than 0, I'm still above, but since it's greater than or equal to, or on the x-axis. So, to the edge of the smartboard there. So I'm going to have solid dots here. And I still want above, also on. And so when I flatten out my x's, because I'm looking at just the x's again, it looks like this. Now, 1 is okay to put in there because when I put 1 in for x, I'm going to have 0 greater than or equal to 0. That is a true statement. So it's okay to have the 1. So really, like, I don't care to put this in my interval. It would not be simplified if I had it as 2 pieces. This is just 1 piece. Because the x value of 1 doesn't matter. So my interval is actually now just from -3 with a square bracket. Because I do have an x value of -3, I will include the -3. It does make the inequality true, up to infinity, and infinity always has the round brackets. So that is the difference between those 2 pieces.